Hi, my name is Annie Glassie. I'm an Associate Systems Engineer at HawkEye 360. Welcome to HawkEye 101. Today we'll be talking about how HawkEye 360 works with radio frequency signals, or RF signals, so that our customers can quickly gain insights that serve their missions. As we said in our last 101 video, RF is a unique source of data because much of our digital world operates in the RF spectrum. This means looking at RF activity gives us access to a wealth of information about global trends and activities. For example, our customers have used RF data and analytics to spot Chinese fishing vessels encroaching on the Galapagos Islands, to identify poachers in an African park, and to detect tankers smuggling oil from Iran to Syria. You might be wondering, if RF is such a valuable resource, why isn't it more well-known or used more often? That's a good question with a somewhat complex answer. First, think about the space industry in general. Today, the new space market is booming with innovation, due largely to the fact that more sophisticated technologies are becoming less expensive and more accessible to commercial entities. RF is a unique case because, unlike data sources like satellite imagery, there has been little experimentation in using it commercially. HawkEye 360 is starting from scratch and leading the field in not only detecting RF signals, but also in developing innovative methods to better use these signals and discover what they can tell us. As a result, even experienced geospatial intelligence analysts may have limited exposure to working with RF. Unlike other widely accessible and known sources of intelligence, like satellite imagery, synthetic aperture radar imagery, or classified signals intelligence. Today, RF signals are more accessible, however, interpreting and understanding the data is still a challenge. Historically, understanding radio frequency required users to have sophisticated niche RF experience and advanced degrees. Even those that are familiar with RF have had to trudge through an arduous process to derive any meaning from the RF data they've collected. At HawkEye 360, our goal is to make it easy for anyone to understand and use RF data, whether they work at an intelligence agency or a nonprofit organization. That means a big part of what we do at HawkEye 360 is developing sophisticated analytics. Instead of sorting through data for hundreds, thousands, or even millions of individual RF signals, our customers can quickly identify the information or data points that matter most to their mission. By approaching RF data and analytics in this way, we can help analysts do their job faster and with more confidence. With all this in mind, what specifically can HawkEye 360's data and analytics tell customers? The first level of insight we provide is geolocation data. Simply put, we can identify where signal emissions are coming from. We can geolocate a growing library of signals that come from enterprise-level equipment, such as marine vessels, radio systems, radar systems, satellite phones, and even emergency beacons. When you look at our geolocations on a map, you might also notice ellipses around various signals. These ellipses speak to the accuracy of our geolocations. Overall, geolocation accuracy depends on several factors, such as the emitter type, the power of the emitter, how active that emitter is, and more. Our algorithms are designed to create ellipses with a 95% probability that the target emitter is contained in that ellipse. So if I'm an analyst monitoring a country's border, HawkEye 360 can show me where along the border there are L-band geolocations, push-to-talk radio geolocations, and other signals I might be interested in. The second level of insight we can provide comes from additional information we glean by looking at external signal characteristics. For example, if we are looking at VHF digital selective calling signals, we may be able to demodulate a mobile maritime service identity number, or a MIMSI. If we're looking at other VHF or UHF signals, we might be able to determine what channel number is being used by the respective push-to-talk radios. These small additional details can act as context clues for analysts, giving them further insight on the activity they're seeing and whether it's significant. For example, in our country border scenario, an analyst might see several geolocations for push-to-talk radios. The precise RF frequency or signal externals might also tell him or her which channel numbers are being used. If there are two emitters close to one another and they're on the same channel, the analyst may infer it's likely that they are in communication with one another. On the other hand, if they have different channel numbers, there may be several different conversations going on. The third level of insight we provide comes from putting our RF data in context. Customers can look at RF activity for a specific area of interest over time to establish a baseline of activity. Customers can also use our RF data and analytics to tip and cue other sources of intelligence as part of a multi-int solution. In our country border situation, we could determine if the push-to-talk radio we discovered is potentially suspicious by comparing it to historical RF activity in the area. If it does seem potentially abnormal, we could deploy satellite imagery to investigate further. If not, we potentially saved ourselves from deploying unnecessary resources. RF can be combined with AIS data, imagery, SAR, open source intelligence, and social media analytics, among other things. You could think of RF data as little flags that tell an analyst where to look, when, and when to take further action. Geospatial intelligence entails bringing together several different types of data to create a more complex picture. As a pioneer in the commercial RF domain, our goal is to build RF into the Stato ecosystem as innovative and powerful new tool. We aim to make RF geospatial intelligence easier to interpret for any analyst, regardless of experience level, across various market verticals. In addition to providing accurate geolocation data, we are working to further integrate other sources of intelligence, machine learning algorithms, and other technologies to amplify the value of RF and empower customers to gain actionable intelligence to support their mission.